In the deep ocean, it's so dark that animals have to get creative and make their own light to lure prey. This is called bioluminescence. Closer to the surface, creatures like jellyfish also seem to glow. But without the sun, they can't glow. That's because jellyfish fluoresce. They need to absorb light in order to glow. Today, we'll talk about jellyfish and types of fluorescence. These little guys called electrons in jellyfish can absorb the energy from light. That makes them really excited. So we say those electrons are in an excited state. Here they have lots of energy to bounce around, have some fun. But just like us, being in an excited state, it's a lot of work. They can't sustain that for long. They need some sort of way to release that energy. Eventually, that excited state will fall all the way back down. If you notice when it did that, it actually glowed. It released all of that extra energy as a little bit of light. Human science people call this glowy stuff fluorescence. Because it happens quickly, they call it prompt fluorescence, aka quick fluorescence. Sometimes weird things can happen when electrons absorb light. After absorbing that energy, sometimes that little guy gets flipped. It's in some sort of upside down excited state. Science people call that a triplet excited state. From here, it's hard to go back down to that lower energy, comfortable state. You can imagine that little guy would have to flip upside down again. That takes a lot of effort. But he's not stuck there forever. If another upside down triplet excited state comes close enough, bam! Well, there's one guy in the low energy state, but where'd the guy with the glasses go? He absorbed both their energy and is in some sort of super excited state, and now he's able to flip back over and come all the way back down and do the glowy thing again? What? How did that guy do that? What's really going on here? This is what science people call triplet annihilation. Two of these upside down states find each other and make one relaxed, low energy state and one excited one. And just like before, that excited one has too much energy and has to get rid of it by doing that glowy thing and releasing light or fluorescing. So what's the difference between the two, this prompt and this other glowy fluorescence? Well, when light comes in, you can either get a right side up or an upside down excited state. It's really easy for that right side up one to just relax down and release some glowy light. That's called prompt fluorescence. The upside down state needs to find another upside down state so that they can combine their energy to create one relaxed state and one excited right side up state. Now that right side up excited state can relax back down and release some more glowy light. But this whole finding each other and combining energy, it takes time. That's why this fluorescence is called delayed fluorescence. And that's the difference between prompt and delayed fluorescence.